when you're asked to solve a quadratic function or a quadratic, you need to determine or find the x-intercepts. That's what you're asked to do. And remember, y is equal to 0 when you're trying to find the x-intercept. Note, I want you to know this, and some of you may have run into this already. X-intercepts is the exact same as the roots. Okay, roots, that's an R, I promise. Okay, it's the exact same thing as roots is the exact same thing as zeros. Okay, so that's what solving quadratic equations means. Okay, there are two methods of solving quadratics. Using the quadratic formula or using a graphing method of your choice. So this, you already have done this. I will just show you that you're doing the same thing. Okay. So this is new today, the quadratic formula. So here's the quadratic formula. Okay, if you're given the general form, right, it has to be in general form. If you're given an equation, a quadratic equation, and it's in general form, we can find the roots by using the following formula. And notice that I'm using roots, right? What are you really finding? Way up there, x-intercepts. It's the same thing. Okay. So here's the formula. Ready? This should be on your study sheet as like by the end of today. To find the x-intercepts, we're going to go minus whatever b is, plus or minus square root of b squared minus 4 times a times c. I'm actually going to make this line. I'm going to use a red pen to make this line because a lot of students get this part wrong because it spans the whole thing. So from the beginning of your equation all the way to the end, right, all of that is going to be divided by 2 times a. Looks scary, but it's okay. I promise you it's going to be fine. Okay. We have a name specifically for this part. This part right here is what we call, if you take that part out, we call it that the discriminant. So it actually discriminates in this case. It tells you what's going to happen, right? It kind of like, if that part inside, right, if you do the root part and it's positive, the value itself doesn't matter, but if it's positive, right, you will have 2 roots or x-intercepts. Okay, you're guaranteed you can have 2. If that discriminant is exactly equal to 0, right, you'll only have 1 root or x-intercept. If that is negative, can you take the root of a negative number? You can't. I mean, you technically can. It's called imaginary numbers, but we're not going to go there. No roots, x-intercepts. Actually, as I'm doing this, I need to go back up to where I say x-intercepts is equal to roots is equal to zeros, it's also equal to solutions. Are you kidding me, right? So many nicknames. Make sure this is down first. And then we're going to go up here. Solution or solutions, right? So it's always root or roots. X-intercept or x-intercepts. Zero, the zero or the zeros, right? So it's, there could be one or two, right? That's why we have to write it like that. Or there could be no solution, right? So these are all saying the exact same thing, folks. Okay? So I want you to think of it this way. It says, hey, find the roots. Oh, I know that y is equal to 0 at that point. Find the x-intercepts. Oh, I know that y is equal to 0. Any of these words, if you see that, you know this. Okay, immediately. So how about this, to make things very clear, right? This is when you see that y is equal to 0, right? To make it abundantly clear that you understand that you're finding the x-intercepts. And let's get cracking. Let's do some work. Let's use this formula already, okay? Probably wondering, that looks so scary. What's going to happen? Why is there a plus or a minus here, Mr. Dirksen? That's just to save you space. Because this formula is saying that one of the x-intercepts can be found by going minus b plus the root divided by 2a. And the other x-intercept will be found by going exact same thing, except for you're going to go minus that root over 2a. So instead of me giving you two equations, we just write it like that, plus or minus. That's what that is saying. Okay? Keep that formula up because I'm going to use that for this part. Solve the following using the quadratic formula. So I need you to use it. If I specifically tell you to use the quadratic formula, you have to use it. You can double check using your calculator, but okay. So solve the following using. So you should think of, how about bubbles, right? You should be thinking of y is equal to 0, right? So we'll make that 0. Y is equal to 0, so we plug in there. This is 3x squared plus 3x minus 3. Does that look like general form to you? Yeah, no brackets, right? General form, we can use that. So a is equal to what? Whatever's in front of x squared, that's a. B is equal to 3. And c is equal to 3. No, negative 3, right? So the sign follows you. So this is the first step. Before I use my quadratic formula, I'm going to get my a, b, and c. Please do not say that a is equal to 3x squared. That's wrong. It's just a coefficient that I'm after, right? All of the numbers. Okay. So here we go. Let's use our formula. I'll write it out this time, okay? And notice that the one I gave you has brackets. Did you see that? Because we're going to insert into the letters, we're going to insert values. So here we go. X is equal to negative. What's b? B is just 3. Plus or minus. B squared. So it's 3 squared, because b could be negative. Watch out. And squaring it would turn it into a positive. Minus 4 times a. Lots of 3's here today, right? And c is negative 3. All of that, all of it, guys, is 2 times a, which happens to be 3 as well. I feel like using a highlighter here, but I think I'm just going to leave it. Or I'll use a highlighter. So I'll do A is 3, right? So wherever there's an A, I'll highlight that green. That's the only time. Oh, actually, it also shows up here. B, use a color and just be consistent, right? B shows up here and here. So we insert it there and there. And C is -3. C only shows up once. And now this whole thing can be simplified quite a bit, okay? So what I do here is this. -3 times 3 is just -3, right? Plus or minus. And here you use your calculator for this part. So grab your calculator. And you need to be careful here with this, okay? I'm actually going to use the brackets. 3 squared minus 4 times 3. All I'm using is brackets, right? Times -3. And when you type in this negative, you need to use the negative button, not the minus. Okay? So I'm actually typing in the discriminant into my calculator like that. And you hit enter, and you get 45, correct? You should be getting 45. So this part right here is 45. Don't forget this part. All of that divided by 2 times 3, which is just 6. And now you stop for a bit. You're like, my discriminant is positive, correct? How many roots or how many x-intercepts will I have? 2. There'll be 2. So should I do this here? Discriminant. I'll just do that here. Discriminant. Positive. Therefore, 2 roots. Okay, I hope you can see that because I'm going to need this space on the side to complete my calculation. So from this, you branch off. I'm going to branch off to the top here and say that the first root is going to be -3 plus, look at my finger, right? Plus root of 45 divided by 6. Let's figure out what that is. Look at my calculator. I'm going to go -3 plus second x2 is for root of 45. And then you hit enter. You divide that answer by 6. I hit enter and then divide by 6. So you get 0.62, which means that the first x-intercept is this. This is just the x value of that x-intercept. We know that y is equal to 0. We're doing good with time. Then you go back. Branch off to your second answer. The second x-intercept, I call that x2, right, is going to be -3. So go back to this part here. And in this case, it's going to be minus root of 45. All of that divided by 6. If you look this up on YouTube, teachers do it a whole different variety of ways, right? Sometimes the root is nice and it's a perfect square, like 36, right? 81. But for us, it's rarely gonna be the case. Okay. So watch what I do. This is a little trick. I go and copy this part that I just did before. I copy it down, and I will just change that plus to a minus. Hit enter. Don't forget to divide by whatever is in the denominator. That's -1.61. Sorry, -1.62. So it's -1.620. Okay, so that is how you find the x-intercepts using the quadratic formula. So Mr. Dirksen, do you mean that the AC we just did I could have used this to do the AC to find the x-intercepts. No, because that one was in vertex form, right? So if you FOIL it out and do all of that and turn it into a general form, you could have, but I think that's a lot more work, right? So real quick, I need you to see this. Let's type this equation into our y1. So I'm going to go 3x squared plus 3x minus 3. I'm going to graph it. Sorry, if I go a little bit too fast, it's just because I know you know how to do it. And I still use that previous window, which is not what I want. So zoom 6 gets you back to the original. There it is. I'm already making y2 equal to 0. Let's just check one of them. Okay, I don't want to. So I'm going to hit enter, and lo and behold, what do you find? 0.62, just like we calculated here. And I can guarantee you the other one is going to be the same. 100% guaranteed. I want to do one more before we go. So tomorrow I will AC you on this. How's that? What if you have something like this? Whoa, that does not look right to me. You will do this. You either bring all the terms that are on the right-hand side, you bring it to the left-hand side, or vice versa. Okay? Bring all terms over to one side. You pick. Okay? One side. So that you have equal to 0. Okay? I'll bring everything to the left. Okay, so 8x squared. I'm kind of underlining the x squares here. So the 3x squared comes over, subtracting. Right? I brought that over next to that x squared. Then I go plus 5x, because the 5x is already on the left side, right? I go look on the other side. There's let's circle the x's. Okay? So 5x is already there. This 4x comes over, crosses the equal sign, changes to plus 4x. And then what are you left with? You have that 7 still. This 7 is already on the left-hand side. You put it there. And there's no constant on the other side, right? So what are you left with on the other side? 0, right? Zip. That's what you want anyways, right? You want this to equal to 0 when you're using the quadratic formula. So then you're left with 5x squared plus 9x plus 7 is equal to 0. Perfect. Now you're ready to go. A is equal to 5, B is equal to 9, C is equal to 7. So let's go. X is equal to negative 9 plus or minus 9 minus 4 times A times C. Make sure everything is under the root there, okay? Extend your root as long as you have to make everything fit. All of that divided by 2 times A. Clean it up. Negative 1 times 9 is just negative 9, plus or minus square root, and then type that in. Brackets are very important when you have negative values. Oh, I forgot something here. This is supposed to be squared. My bad. Right, that's squared. Don't forget that. So it's really 9 squared minus 4 times 5 times 7. If there are no negatives, I don't really use brackets. Just a little secret here. Uh-oh, negative. What does that mean? That means that there are no x-intercepts. This thing doesn't have any x-intercepts. That's what that means. So discriminant is negative. Therefore, you're laughing now because there's no more work to be done. No roots. No roots. No solutions. No solution. no x-intercept, no, what's the other word I used? Zeros. No zeros. You're saying the same thing over and over. What's the time here? I've got 5 minutes. I think I'm just going to leave it there. I'm going to park it. Homework, it's at the bottom of this page, right? I would say these ones are the easier ones. I will show you a few that are a bit more challenging tomorrow. But you should be able to do a simple one, like one of these two basically that I gave you. You should be able to do that by tomorrow, okay? Thank you guys. As always, you're awesome.